Hello everyone, very good morning to one and all. I welcome you all to the next technical session of the FGP on the topic of image dataset creation tool by Mr. Anubhav Patrick. Mr. Anubhav Patrick is an NVIDIA Deep Learning Institute ambassador and certified instructor. He is the coordinator of the Data Science and Deep Learning Center of Excellence at KIET Group of Institutions, Ghaziabad. He has been part of the Leading India.ai initiative and has delivered several workshops and talks on AI and ML across the whole country. He is also a mentor and ambassador of deeplearning.ai. Mr. Anubhav has published SCI indexed paper along with national and international patents. Welcome, sir, to this workshop and over to you for the technical session.
Thank you, Madhuman. Okay, so let's start today's session. And the session that we will be discussing will be on dataset creation for computer vision tasks. So basically, this is the outline of our session, that these are the topics that we will be discussing throughout this session. We will start with with understanding of the complete ML pipeline and the data tools that we use in the ML pipeline. Then we will see what are the resources for finding the existing data sets. Then we will be discussing about the challenges in dataset creation. Then we will be discussing about when we are required to create our own data set and when we can use existing data sets. Then we will discuss something about acquiring data, how can we acquire data. Then we will discuss about little bit about data augmentation. After that, we will discuss about how we can annotate data for computer vision. Then there will be some hands-on demo of NVIDIA Digit software, Intel Cvet software, and IEEE Dataport software. All these three software have a different purpose, and we will be discussing the different purpose of these software. And lastly, we will be discussing about one popular data science competition, particularly data competition that is going on, and it's very popular. And you can participate on your own, or you can ask your students to participate in it. So let's start with it. So let's discuss about the complete ML pipeline before thinking about data and data set. So, okay. So we will start with any ML project. During this discussion, I will be discussing with you one of the projects that I have built recently for a company called Ferromatics. So all the things that I will discuss, I will relate with that project so that there will be some consistency. So there will, if you talk about any ML project, there are 4 stages: scoping, data, modeling, and deployment. 4 stages are built whenever we discuss about any ML project. So let me just share one more screen. Okay. Okay. So what happens is this, like we recently built a project for a company called Ferromatics. And for that particular project, the first thing that we did was scoping. Scoping basically means that defining the project. We had the meeting with the stakeholders, particularly the company. There is a company called Ferromatics, and they are building. They are particularly working in AI assisted livestock farming. So what they do is, it's a US based company, and what they do is they use AI techniques to increase the production of their livestock farming stock. They are particularly we were working on with a robot called Chicken Bot, and that in that particular problem, what we need to do was we need to find out the activity of different chickens, that whether they are laying dormant or whether they are active, and based on that they will be using that particular model further for like finding out whether the livestock is having some disease or there is some issue with the livestock, because if the activity is low, then it means that there is some sort of an issue with the livestock, and it will raise an alarm, and the livestock, that particular owner of that livestock farm will get alerted. So first, the very first thing is scoping that what our project is trying to do. Then the next thing is data. That is the next particular phase. And in the data phase, what we do is we define like what data we will be requiring, and we define what are the sources that we will be getting that data from, and then we establish some sort of a baseline that what are the things where that we will be annotating, and what are the things that we will not be annotating and we will be leaving out, and what are the edge cases that we need to consider, and these kind of things. These are all called your data part, and in data part we establish the data baselines. Then definitely we label and organize our data. We convert it into a format that can be fed into ML model. Then there is modeling phase, and in modeling phase there are so many algorithms for different machine learning tasks. We started with YOLO 3, then we moved to YOLO 4, YOLO 5, then there was RCNN. Ultimately, the purpose of that particular project was to localize the activity of chickens. So for that, we utilize different these kind of object detection and then object tracking algorithms. Then perform analysis that if our model is performing low, then what can be the reason, and finally deploy it on an edge device or any particular deployment environment. Our particular project was particularly you can say was particularly focused on deploying it on a Raspberry Pi that was mounted on top of a camera. So that is about ML pipeline. So let me show you what I'm trying to say. Let me just show you a simple video. Okay, I hope my screen is visible and everything is fine. So this was our project, and in this project, if you can see that what we were trying to do was that the company gave us these kind of videos. They were having cameras in their farm, in their livestock farm, and the camera collected different videos, and even there was some scenario in which the camera was mounted on top of a moving robot or moving sort of a device that moved around the entire farm. And our task was to find out that whether there is some part of the farm where there is the movement is very slow of the chickens, and that may be symptomatic to that there is some sort of a problem with those chickens, and they may be sick or they may be hurt, and an alert can be generated. So this was our project. So first of all, when we met with the stakeholder, with the company, what they did was they defined the problem, and they told us that what they wanted us to do. Then they gave us this particular data. That was the data part. Our task started with this data. There were so many feeds. This is one video. We had around this kind of maybe more than 200 to 250 videos, and like they were ready to provide us even more videos like this. And those videos were shot in different forms. This is one particular farm. Different farms had different lighting conditions, different layout, different sort of a angle of the camera, and so on and so forth. So this was our data part. Then after we scope the project, that what we will do, what we will not do. We will discuss about this scoping the project, in which we decided that these kind of chickens we cannot track. One of the issue that we faced was that the the FPS, the frames per second, was very low. Initially, the videos that were provided to us, the FPS was very low. Okay, so sometimes you are required to again recollect the data. I'm telling you from a personal experience. So if we talk about our ML pipeline, you can see that sometimes we go back again to recollect data. So why we will recollect the data? We had a meeting with the stakeholders and we told them that uh, the frames per second that they have provided us is too low, and between two frames the chicken moves differently at different locations, so at sometimes at very high pace that it's very difficult to track them. That one frame chicken was somewhere here, and in another frame chicken was at totally different location, so it's very difficult to track them. So they recollected and gave us some newer data, and after that we re-annotated and then we moved forward. So this was our data part. Then modeling part was there, that we utilized. First of all, we labeled the data using different different tools. At that, in modeling part, we used object detection and localization algorithms. Then deployment, we were given a strict deployment scenario that we were required to deploy whatever we were creating on a Raspberry Pi on top of their cameras that were located in the farm. So this is all about ML pipeline. Okay. So before moving forward, let me tell you the hierarchy of an ML team, that what ML teams in reality look like. Sometimes, like majority of us are academicians, and we do not have like hands-on experience of what ML development looks like. So let me tell you, like this is a typical hierarchy of a ML team. And in MLT, there are different roles. Like we have data taggers and data wranglers. Sometimes we also call them as data labelers. So their main task is just labeling the data and preparing the data to fed into the model. Then we have multiple junior ML engineers. Those junior ML engineers just like they are fresh graduates or have 1-2 years of experience, and they simply assist our senior ML engineers who decide which algorithms will be better or which particular different direction they can work upon. So junior ML engineers, this is ML engineers, senior ML engineers, and then there is a single lead ML engineer. That particular lead engineer lead the whole projects, and then there are some technical mentors across the company who can help you if you get stuck, or give you some insight if you want like their opinion. So this is what a typical hierarchy of a ML team looks like. Now, before moving forward and discussing about our dataset creation, I want you to go to this particular site, pigeonhole.at, and enter this passcode, Atal Data 1, and tell me how many tools you think are required to complete all these steps. Like I can share with you with this experience that recently the project we did, that how many tools we utilize. So I want you to just go to this particular site, and just enter this passcode and just give me a reply that how many tools you think are required in the entire ML pipeline. Maybe 2 tools, you think 3 tools, 4 tools. How many different tools are required to build entire ML pipeline? I'm giving you 2 minutes. Just go to this site and give me your opinions. So that we can look at the beauty and as well as the complexity of the ML project that we build in real world. Just go to the site, enter whatever you think is the appropriate answer, and then we will discuss like how many actual tools are required. Just few seconds more. Just go there and just think about it, that how many tools may be required for these particular like stages of the ML pipeline. How many total number of tools will be required? Okay, so let's see what is the scenario. Okay, so this is like this is the answer that we are getting, that uh, around 20% people say that we require 3 or less tools. 36% people say that we require 5 or less, and 45% or more say that, now 50% or more say that we require more than 50% of like more than 5 tools. So the answer is more than 5, and let's see what are those tools that we require to build actual ML systems. So let me tell you, like from my personal my personal experience, that it's in the real world it's very different. When we talk about machine learning, when we perform we build actual products, it's extremely different than what we do in academia. Like they're totally different. What I'm trying to say is, in academia, okay, so in academia, our major task is this only, this part only. This is an overview of machine learning tools that we are required. We will discuss we'll have an overview, but in academia we are just focused on building models and getting some results and getting it published. So our major focus in academia is only this part, this small portion of the part. Normally what we do is we use some pre-existing data set, then we build some models, some any data set. Like recently COVID situation was there, so thousands and thousands of papers were published on COVID detection, maybe COVID detection on X-rays, COVID detection on our CT scan images, and COVID detection on our you can say different using different sensors. So lots and lots of papers were published, but 99% of them were focused only on using some existing data set and just finding some result, and if the result was good enough, people were publishing it. So this was only this much part. But in real life, like when we talk about this scenario, like when we talk about the project that we did, so our task was not only to just get a model and just find some result and just write some paper. Our task was very different. We were required to get data, even though data was gathered by the company itself, but from data to final deployment, there were so many stages, so many phases, and it was very, very different than what normally people do when they are in academia. And so that is something that is hidden from academicians most of the time. So let me just tell you, like, what are the different tools. So particularly we will focus on this section, data section. Then apart from data, we have so many tools like for data, from gathering data to storing data to labeling data to versioning data. All the tools are here. Then we decide where we want to train it. We were When we did this project, we used Azure cloud. We had Azure cloud subscription, and we had their models, machine learning not models, machine learning machines are available. Their virtual machines available, and we trained it on those particular machines. Then if we talk about our local infrastructure, if we are performing in-house training, then we may require resource management, we have something called Slurm that we use in our DSDL, our data science and deep learning supercomputer called Param Shavak. So we have a supercomputer, and in that we use resource manager. We have like Docker is there, then we have Slurm is there to actually balance the resources. If we talk about different users, if they try to access it, so we require some sort of a resource management. Then software engineering is there, that how you will write the code using your Git, your Jupyter notebooks, your Python files. So these are things. Then we have frameworks and your machine learning libraries. We have PyTorch, we have TensorFlow, and we have sklearn, and we have so many, like AutoML is there. Okay, Auto TensorFlow is there. So these kind of libraries are there. Then experiment management is there. If you're training, then what is the scenario, like how is the model being trained? Is the accuracy going up? Are the different metrics that we are targeting improving or not? So this experiment management is there. Then hyperparameter tuning is there, that like we all know about hyperparameter tuning. We have all studied about deep learning, and there are certain software that can help us in hyperparameter tuning. And lastly, we have our deployment. In deployment, first of all, we have to convert it in a particular TensorFlow format. Like initially, we tried to convert it into TensorFlow Lite, and then we also converted our model, this particular model that we built on PyTorch Lightning, and then we deployed it on the edge device. So that depends whether you want to deploy it on a server. Our task was on an edge device, so we deployed it on an edge device. Okay, now particularly this session is all about the data. So we are focusing on this particular scenario. So in data, there are so many things to consider about. Like first thing is the sources, that where data is stored. Like you can have your Amazon S3 storage services, or you can have some sort of a database like NoSQL databases. So there are so many sources where your data can be stored. This particular data was shared in form of a Google Drive, but it depending on the scenario. You can have different sources on which your data can be shared. Then, if you talk about large project, this was a small project. It was not nothing spectacular, but it was a small project. But if you talk about very large project, then data comes from various sources. So in order to gather that data, we require something called data lake or data warehouse that gathers data from different sources. So for that, we have Google BigQuery is there, then Amazon that Red Bricks is there, then Databricks is there, Snowflake is there. So these kind of softwares are there that can be used to gather data from different sources. Then, if you want to perform some sort of a analytics on that data, then you can use your Spark. Initially, we used to use your MapReduce. Now Spark is there, then Dexter is there, and like multiple softwares are there to perform big data analytics. It's not required, but if you want, you can do it. Then for exploration part, that is very important, that we always do. We use Pandas, we use NVIDIA Rapids is there, that is similar to Pandas, that particular thing runs on your GPUs. Then DBT is there, and like multiple softwares are there that can be used for exploration. Then labeling is there, that is one of the most important part that we will be discussing today. So there are so many tools and those so many companies that that provide us data labeling services. Then so we have to think about how which tool we will be using and how we will be performing data labeling. Like we will be discussing about a little bit about Cvet tool in this particular session. And then versioning is there. Normally for versioning we use Git or GitHub. But the issue is this: when we talk about ML models, then ML models can go in terabytes to petabytes of size, depending on the situation. Like latest GPT-3 model is there for natural language processing, and latest natural language processing models that we are receiving nowadays are so huge in size. So you cannot use your Git or GitHub for version control. So we have special tools like DVC is there, liquid data is there. So there are so many modern tools that can be used for versioning, but those tools are only used for very large projects. For smaller projects, these are not used. So all these things, these are not required. That depends on the project. For example, when we talk about this project that we did, this was a small project. It was not very big. So we skipped majority of the tools. But if we were trying to create it on a large scale and trying to deploy it on a large scale, then we might have moved toward different other tools that we have discussed in these in the ML tools that we have just studied. Okay, so this is an overview. Then there are certain services like we have Google Cloud, Amazon SageMaker, Gradient is there, Paper Space. Then we have Floyd is there. Then Microsoft Azure is there. So there are so many different online vendors that they provide majority of these tools in a single coherent platform. So we can use those services as well rather than using or choosing individually these tools. Okay, so moving on. Next question that is very important before we actually begin our session. Code versus data. It's a very simple question. My question is this: what do you think is more important? The code, the model that we build. Okay, so we could have used YOLO V3, YOLO V4, YOLO V5, then we have mask RCNN, then faster RCNN. So many RCNN variants are there if we talk about this object tracking. So my question is this, that what do you think is more important, the code or the model, or the data that we are working upon? What is more important? What should we focus more on while creating a ML project? I will give you my hands-on experience that what we encountered when we recently built this project. But I want you to understand, I want you to ponder upon whether code is more important or data is more important. So just go to this site again, pigeonhole.at, and just enter this code Atal Data 2, and just tell me, what do you think? Should we focus more on code? Let's read the most recent research and let's find out what the state of the art model that the researchers have created and use it in our problem. Or should we focus on the data, that the data we are working upon? Let's focus on that data, and we can use any acceptable model that comes pre-built in majority of the frameworks. If we talk about TensorFlow, if we talk about PyTorch, these are the two major frameworks that we use in computer vision these days. Even OpenCV, if we do not talk about deep learning. If we talk about OpenCV, then OpenCV also has so many built-in your computer vision algorithms that we can directly utilize. We don't have to write even a single line of code. We can just use their APIs to find out, to solve the task that is at our hand. So my question again, I want to repeat my question. What is more important according to you? The code, the model, the state of the art, latest research in a particular that is related to a particular problem, or the data on which everything will be built upon? Just think about it and just go at this particular site and answer it. I'm giving you just 1 minute, and then we will move forward and we will discuss about different things that we need to discuss about dataset creation for computer vision. So 1 minute, just go to the site, enter this code, and give your opinion. Just 20 seconds more. So just visit this site and give us your feedback, that what do you think is more important, code or data? All right, so let's try to see the answers that we have received. Okay, so 12.5% people are saying code is important, and we agree that code is important, but 87.5% people are saying that data is more important. Okay, and let me reveal the answer from my hands-on experience or from my personal the experience while developing some projects. So the answer is data. Let me tell you. So when we built this project, there were so like our team was quite big, and the different participants, not participants, the different team members tried different models. Some people tried PyTorch, some people tried TensorFlow, some people tried YOLO different versions, some people tried your the light versions of YOLO that can be deployed. Some people tried RCNN and its cousins. Okay, so around 9-10 algorithms we tried, and let me tell you, there was not so much difference in the number of chickens that we were able to detect, or in the accuracy that we were getting. There was some difference, but it was not that much of a big difference. It was a very limited difference that we achieved. So majority thing that affected us was the quality of the data. Like just I shared with you earlier that initially the frame rate was very low. So it was very difficult to actually do what the company was asking us to do with that video feed that we were getting. We improved that. Then we focused on labeling. And after we did labeling, we improved it. We will see that how labeling can be improved when we will discuss about Cvet. So we improved the labeling, we improved the annotation. Okay, and with the improved annotations and with the improved video feed, the accuracy got jumped or got bumped to considerable margin. It becomes acceptable to the company that okay, yeah, whatever we have done, they said that we are okay with it, and you can just deploy it on the edge device and provide it to them. The source code was required by them, the model weights was required by them, and the final deployment is the steps to deploy it in their actual hardware was also required by them. So the majority focus, or the majority of the focus of any ML project must be on data. Okay, and let me tell you one more thing. The code that we used finally, that is also already available in TensorFlow. We didn't write from scratch. That was already available to us. The only difference that was there was on data. As soon as the data quality improved and the annotation improved, everything becomes so good and everything became acceptable by the company. So this is what I'm trying to say. So okay, so what is more important? Data is far more important than code, because right now the state of art have been already achieved in majority of tasks in computer vision. So these things are already provided to us. Even the models are pre-trained. We can use transfer learning, and there are so many good models for different tasks on different frameworks. Just go to TensorFlow or PyTorch documentation. You can see that there are so many models that can be helped, that can be used to solve our problems. So our major focus should always remain on data. If we have good quality data, then we can most probably able to solve that problem using ML. If we don't have a good quality data, then most probably, no matter how good state of the art algorithm we will choose, we will not be able to solve the problem in real world scenario. One more thing I'm trying to highlight is we want to do it in real world. We are not like it's not something like some sort of a you can say an experiment that is going on within a classroom. We want to deploy it in the real world, and in real world, if we want to deploy it, then it's very important that we get acceptable quality, we get acceptable accuracy, get acceptable metrics, and the performance is good enough, and we are able to deploy it. This is what that is what is required in the real world. Okay, so just like we have just seen, 80% of the work that we should do while doing an ML project is focus on the data. Try to improve it, try to improve its quality, and only 20% we should worry about code. And even I will even say that even 10% code, like even 10% focus on code will be more than enough. Okay, so I'm getting some sort of a noise. Ashish Bajpai sir. Okay, so if it so if we just summarize whatever we have discussed, data is the food for AI. So if we don't have good quality data, it doesn't really matter what we do, how much state-of-the-art algorithms we have, we cannot do anything that is acceptable in the real world. Okay, so 80% of our task is revolving around creating high quality data sets and high quality data that can be ingested inside our ML algorithms, and finally it can be deployed. Our project went around for 2 months. This project was for 2 months, and for around 5 to 6 weeks out of that 2 months, we were just focused on our data part. Okay, because data annotation and data preparation is a very cumbersome process, and especially in videos. In images, it's easy, but if we talk about videos, each of this particular video consists of hundreds of frames. So it is consisting of hundreds of frames. So it's very difficult to annotate and prepare the data. So majority of our focus was on not was is on data preparation and data annotation. Okay, so if we talk about, like, if we have some data and if we want to improve that data, if we cannot just you can say, if you cannot if you have some model and you cannot just increase its performance, then what is the easiest thing through which you can improve the overall performance of a model? You cannot just change the code of the model. You cannot just randomly try to alter the model. Then the easiest thing to do is to add or improve data. So let's say you have some model, and you have let's say F1 score or precision or accuracy or your recall at an below acceptable level. So the first thing that you can do is try to improve the data, try to improve you can say the annotation of the data, try to add more data, and then retrain the model and see what results you get. Even if after doing all these things, all the data processing or the data improvement, then you can think about creating a new model. But first focus on data. So whenever you create any ML project, and if you find that everything is good, the model is it's okay, you have used it from the repository of TensorFlow, PyTorch, or any state-of-the-art library, and you are still not getting acceptable accuracy, you are getting, let's say, 70% accuracy, 75% accuracy, but it's not accepted by you. So try to add more data, good quality data, improve the data by adding more annotations, better annotations, and then again focus on that particular model that you were using earlier. Majority of the time, that will solve the issue. Rarely, if like even if after doing everything you are not getting the results that you want, then you can think about using some other models that are still in research for your particular task. Okay, so good resources for discovering existing data sets. So if you are on a problem, and if that problem doesn't require you to collect new data or create new data set. Okay, let's say you are trying to predict COVID for publication purpose. So you are not expected that you should go to a hospital and get actual or real data, and then go through all the hassle of the privacy and converting it into the correct format, then validating it with the doctor and such kind of things. So what you can do is you can use the existing data set. So if your problem doesn't require you to get new data and new data set, then it's okay. So we have so many resources. If you want to use existing data set like IEEE data port is there, this is particularly useful for academic purpose. So if you are an academician and if you want to use for academic research, the data set you want to use for academic research, you can use this IEEE data port, very good. Then papers with code is there. Again, this is a new addition. Papers with code gives you the latest papers in machine learning, and they have recently introduced our dataset section. So they are also providing you the latest data set in different fields. Then Google dataset search is there. You can just go to this link and Google dataset search will open, and you can simply just write down whatever data you are trying to find, and maybe you'll be able to find it. Then Kaggle is there. Then we have our website. I was a part of this initiative, leadingindia.ai. So we have even listed various data sets on leadingindia.ai. You can also go and find out there. So this is for existing data sets that you can do. Now, my question is this: why data set creation is challenging? So what is the issue with data set creation? What is the fuss about data set and data? What is the problem? Why can't we just go and create good quality data sets? So normally what happens is when we are learning our machine learning development, or when we are just doing machine learning for the sake of publications only, and majority of us do. It's nothing to be like ashamed of. Like it's a part of academia. So if we talk about that, then everything is pre-created for us. Everything is preheated and pre-served for us in a platter. Okay, so what happens is if we talk about COVID, so there are so many data sets are there that are readily available. You can just go to any of the websites that we just mentioned and just get the data set and just get away from the hassle of everything that is related with data set preparation. There are so many things, like there is a privacy concern is there. You cannot just use a data set from a public domain. You cannot just gather data from a public domain and just use it in for your commercial purpose. There is a privacy concern. You cannot, without taking permission of the people about which that data set is creation, if that involves some human, then you cannot just use that data set. So privacy concern is there, data labeling concern is there. Then if we talk about medical data sets, then you require some good doctors who can verify that whatever annotations have been done is correct. So there are so many concerns. So when we talk about that pre-existing data sets, those data sets are like preheated and preserved to us on a platter. But in real world, that is not the scenario. It's very difficult to first gather the data. It's a time-consuming task. The video feeds that I showed you, these video feeds were gathered for months. Okay, I believe they collected, the company collected these video feeds for months, 7-8 months. Then they provided the company to work on this particular data and create that AI model. So what I'm trying to say is it's a difficult thing to create data. It requires so much time to gather the data, to capture the data. Then it requires enormous amount of time to label the data, to annotate the data, and finally you have to deal with the concerns of privacy, of security, of so many things. So it is a difficult task to create a data set on our own. So the majority of the times that the machine learners work upon, that is a toy data set. But real world is very difficult or very different from those toy data sets. Let me one more example that we can see here is, if we talk about some data that we have gathered, maybe it can be of satellite image. So it may be easy to acquire data, maybe easy, okay, because it's not a human labor intensive task. Because if you capture if you put some cameras, if you talk about computer vision, if you put some cameras and just try to capture different like images or videos, then it's an automated task. It may require time, but it is an automated task. So it is equal to, it's easy to acquire data, but it's very difficult to label it. I've told you that it's very difficult to label data. Okay, and especially videos, images data set, it's well and good, but for video it's very difficult, it's very lengthy process, it's very cumbersome process. One image requires you to devote around half an hour, maybe not half an hour, maybe 20 to 30 minutes, depending on the situation, for annotating the data. At least this is what this was the amount of time required for us to deliver the project that we are taking as an example. Okay, then different applications require different sets of labels depending on the scenario. The same data set can be there, but the annotation can be different. And again, you have to re-annotate all the data. Again, your task will become very difficult depending on the situation or depending on the scenario. So different applications require different data labels, and it's a very cumbersome task. Even the companies, the big companies, outsource the data annotation task to specialized company because it's very tedious, monotonous, and difficult task, and it requires human effort. So it will require definitely money to perform data annotation. I told you our project was for 2 months, and for 5 to 6 weeks, we were just annotating data. We were just trying to improve the quality of the data and bring it to an acceptable level. So it is something that requires lots and lots of time, as well as money, as well as effort. Okay. So what could be other challenges that one can face while creating a data set? This is the example that we are taking, our pharmaceuticals project that we created. So what could be the challenges that can be faced while annotating this kind of data set? So let me tell you what were the challenges. First of all, the challenges was that the frame rate was very low, so it was very difficult to track chickens. The second problem was that somewhere, if you can see in the video, some chickens are hidden behind other chickens, so occlusion is there. So how to deal with it? Then the different videos had different lighting. Some had very poor lighting, so it was very difficult to see how chickens are there in that particular frame, and it was very difficult to annotate it. And the device that the company was making required to work in all conditions, at least even in low light as well as normal light. So we had to do with it. Then the quality of camera. What happened was that the company, when they gathered different video footage from their different livestock farms, they used different cameras. Some cameras were very good, while some cameras were very bad. So some had very grainy images, some had very awkward resolution, some had acceptable quality and acceptable resolution. So there were so many challenges while annotating real world data sets, and something that some data set that is applicable in real world. So these are the challenges that we face. Apart from that, other challenges, like we will just quickly go through them because time is passing on very fast. So other challenges in creating data sets, the size of the modern data sets, computer vision data sets, especially video data sets, are very large. It's very money intensive to store them, and it's very difficult, and it's very expensive to store it on a local devices as well as on your cloud. It takes TBs of data storage. Then time availability is again a concern. Whenever we create a project, the company wants the project to be delivered within as short amount of time as possible. So they don't give us that you have 6 months or you have unlimited time, just create the project and deliver it to us. They give us a time frame that you have 2 months or 3 months or 4 months. And it's very difficult to create the data set and high quality data set in that particular time interval. Then completeness, again, that is the very big issue, that maybe the data set that we are trying to create, that is not complete in real world scenarios. It may face some scenarios in which some other or some different type of video feed or image feed might come that we might have not expected, and it might break the system. So completeness is also there, that lighting condition, like in good daylight or in dark light or in some sort of a storm or in fog, what will be the effect. So completeness is there. Then consistent quality data set we need to create. It's something that is difficult. It's not an easy process. You need to maintain consistency. The data annotation team consists of uh, let's say tens of people to hundreds of people. So managing a consistent quality is a difficult task, that every month create good quality annotations. It's a difficult task. Maybe I am creating, some other person is creating, but a third person is creating some very bad annotations. So it will ultimately result in overall declining of the performance of the model. Okay, then data privacy is there. So normally the companies do not allow people to share their private data, even like even if we talk about the normal data set if we create in real world, then also if it involves general public, then their privacy concern that we may have to keep in mind. So data privacy is again very important concern that we have to deal with. Then there is no data standard, like in which format, in which format we want our data. We want it in the form of MP4, AVI, if we talk about video data or image data, and then annotations format is different for different models. So there is no standard way that how we want our data set to be in. Then gender imbalances is there. This is one of the greatest concerns these days, that sometimes the data sets that involve people is skewed against women or some people of different ethnicity. So it is resulting in huge uproar these days. So we need to even consider gender imbalances if we are creating any data that involves human. Then there may be a scenario that there is no way to acquire new data set. It's too costly to acquire data set, or it's not practically feasible to acquire data set. Then we have to think about it, how to get the data set. Then hosting the data set is there, that where you will host the data set. There are so many different providers available to us, that where we want to host that data set. Then there is a concept of data drift, where the distribution of data changes, that initially the data was from different distribution, and when it is deployed it comes in some other distribution. Then this concept is called data drift. So we have to consider data drift, and if data drift occurs, then we need to again retrain our model and redeploy it. So there are so many concerns, but this is very important, that data quality is as much important as data quantity. So you cannot just collect more data and just annotate it badly and think that it will work. So if we want a good data set, then the quality of the annotations must be good, and the quantity that must also be acceptable. So these two are equivalent, that quality and quantity both are required if we want to create some data set on which any ML application can work upon and deployed in real world. Okay, so if we think about the label inconsistencies, there were so much label inconsistencies when we created the project, because different people, the project was built during COVID time and we were having work from home. So different people labeled the images differently. There was not a centralized setup that we sat on a particular place and then we labeled the data. So everyone in his home. So what happened was there was so much inconsistency. If we like, if I'll show you the Slack channel, it is full of those messages, that how to annotate this image, whether I focus on the forward chicken or the chicken that is behind that particular chicken. And there are so many, there were so many issues and so many inconsistencies. So what one need to do is try to find out or measure the inconsistencies, that how much people are differing on the edge cases. Normal cases it's okay, but normally on edge cases, on boundary cases, people disagree, annotators disagree. To find out the inconsistency, then give us a guideline that okay, the team lead or the your ML lead will give you a guideline. Okay, if this scenario occurs, do this. If the condition is very dark and you are not able to distinguish between chickens, just label everything as a single, you can say, animal or a single chicken. So these kind of guidelines are given, and then based on that, we can revise our labeling, and again we can retrain our model and see what are the results that we can get. So if the if there is inconsistency and data inconsistency is there, means the annotators annotated the data differently, but the data set is very large, then sometimes it becomes acceptable. Okay, so if you have, let's say, 2000 videos, and in some of the videos some annotators labeled the data set incorrectly, then again it's okay. It's okay if you have 2000 videos. But if you have only 20 videos or 30 videos or maybe 500 images or 1000 images, and if there is your label as inconsistency is there, then the model will never be able to perform to an acceptable level. So we need to think about it that if your data set is small, then we have to pay extra attention towards your data labeling process. And if the data set is large, then maybe it can be allowed. So data drift and concept drift, there are two particular interesting topics that we need to keep in mind while creating data set. Data drift occurs like when the data distribution changes uh, at the time of deployment as compared to at the time of training. So data drift, we need to again retrain the model and again redeploy it. And then concept drift is also one concept in which the need of the AI software changes, or the requirements of the stakeholder changes. Let's suppose this was our project. Okay, find out the activity of chickens, find out if the chickens are dormant, then raise an alarm because it means that something bad has happened to the chickens. But if the requirement of the stakeholder changes, let's say the company say that now my particular requirement is not only to find out the chickens are dormant, but also to find out how many chickens are dormant. I want to count the dormant chickens that are not moving. So in that particular scenario, the concept has changed on which the model was trained. So if the concept changes again, sometimes we may require to reannotate the whole data. Sometimes the existing annotations might work, we need to retrain the data, but ultimately concept drift as well as your data drift, we may require to retrain and reannotate our model, our data set. Okay, now when to create our own data set? We are required to create our own data set when nothing like that particular data set exists. So we may be requiring to like create our own data set. And okay, so we may be required to create our own data set. And secondly, it must be feasible to collect our data. There must not be privacy concern. There must not be cost barriers. There must not be time barriers that may restrict us. And also, we need to think about how to handle bias. If there is some bias in the data set, then we have to think about how to handle bias. So, moving on, how to acquire data. First of all, there is a difference between data set and data. Data is just the feed that we are getting, and data set means the annotations that we have included along with the data. So, if we talk about how we can acquire data, so easiest thing is web scraping. You can do web scraping, but it's never recommended to use web scraping for real world projects, at least for computer vision. Maybe for NLP, web scraping is a good idea. You can go to the websites for NLP and just scrap the textual data, or maybe you can just scrap the data from various books that are available online. It's good for NLP, but for computer vision tasks, it's never a good idea to do web scraping. What are the other options? The second option is to capture real image and video feeds at the actual place of deployment. That is the ideal scenario, that if you can just go to the ideal place and capture data, your videos and images, then it's well and good. And lastly, if you cannot just go to the actual place of deployment to get the data, then what you can do is you can capture audio or video in simulated environment. And let's just hope that your data drift does not occur, and whatever you are capturing in simulated environment in the real world, that will be as close to it as possible. Okay, so data augmentation, there is one technique, data augmentation. We always perform data augmentation. Doesn't really matter how much is the size of our data set. It's always advised to perform data augmentation. And what you can do is, like, there's all the popular frameworks give us the data augmentation built inside them. So we can just crop different video frames, or we can just zoom different video frames. We can just rotate different video frames. We can just change contrast and these kind of things. So data augmentation is always a good thing. So whenever you create a data set and then you try to train your model, it doesn't really matter how much good data set is there. If it's not a medical domain data set that you are working upon, because in medical domain, sometimes data augmentation does not work. But apart from medical data set, any other data set that you are working upon, it's a good idea to work upon, to perform data augmentation before finally feeding it to the model. We have a very good concept, very interesting concept, very beautiful concept called generative adversarial networks. So if you have the infrastructure available with you, then you can go with GANs for data augmentation. Generative adversarial networks can be used to generate synthetic data. So if you have very less data, and even after performing your normal data augmentation techniques, you are not able to get an acceptable sized data for your ML model, then you can go for generative adversarial networks. But mind it that GANs require extreme amount of computing power. So if we are going for generative adversarial network, we do keep in mind that you must have a very high-end GPU setup, GPU cluster setup, not even single GPU cluster setup. Maybe your, you can say, you have DGX, or you can have DGX pod, or maybe some local GPU cluster, then go with generative adversarial networks. Otherwise, it's not recommended. But if nothing else works and you have a very small data set and you have an access to your high performance computing infrastructure, then you can go with generative adversarial networks. This particular topic is out of our scope, that because we were focusing only on data set creation. But in 2 lines, a GAN works in a very simple way. In generative adversarial networks, we have 2 things. We have a generator and a discriminator. A generator tries to generate fake images, and a discriminator tries to discriminate those fake images with the real images. So these two networks fight with each other and become better and better. And ultimately, if the generator becomes good enough that discriminator cannot discriminate whatever it has generated, the fake images from the real images, then we can just throw the discriminator and the remaining components of the network and just use the generator to create our synthetic data. So this is the concept, but for that you are required to, you can say, a very hard, very high end infrastructure. One GPU will not work, 2 GPU will not work for real world data that you will be requiring clusters of GPU. Then only you can create good quality data set using GANs. So this is just a visual demo. I will share it with you the slides. You can just go to this particular site and see how GANs work, and some visual demo is there. So we will not focus too much time on this particular topic. Okay, so what you can do is just go to this site. The slides will be shared with you, and just see the working of GANs. And ultimately, we have something discriminator and generator, and they are fighting with each other and becoming better and better. And ultimately, the real images will be good enough that it cannot be differentiated from the fake images, and then it can be used to generate synthetic data. Okay, so moving on. So is web scraping a good idea? Normally, no. For NLP, it may be good, but for computer vision, it's most of the time it's not a good idea to perform web scraping to do your data gathering, to just collect the data. It's not a good idea. Okay, so there are even like if there is no other option and you have to perform web scraping. Okay, and you have to perform web scraping. Then there are so many libraries. We have beautiful soup. I particularly like this particular library. Whenever I have to scrap the web, whenever I have to create anything that I need to pass some HTML website, I always use beautiful soup. But there are other websites that you can use to scrap data to scrap website for images and videos and just download them. But for computer vision and for real world computer vision, it's never a good idea. Okay, now this is very important now. So ways to annotate data for computer vision. How you can annotate data. This is the most important part. Gathering, it's okay. You can just place the cameras and record the video, record the images. Okay, web scraping you can also do. Maybe like you are not particular focused on the quality. You say that I will only use web scrap data. Okay, you can even do that. But how to annotate the data? It's the most time-consuming part of any machine learning project. It is the 80% of the time people just focus on annotating data when we create something from the scratch. So what are the options that we have? So we have two different options. The first option is called your crowdsourcing. Crowdsourcing means we offload this labor intensive task to some third party, because if we are a small group or if we have less time, we cannot annotate real world data that we have gathered. Visual data, it's very difficult. So what we can do is we can just crowdsource, or you can say uh, uh, just provide that data to some third party to annotate. So that is called your crowdsourcing. And second option is if we have a large enough team and we have like decent amount of time, then we can do in-house annotation. So if we talk about crowdsourcing platform, we have a platform called Amazon Mechanical Turk. That particular platform is for freelancers. You can find out freelancer on that website, and they can help you to do this labor intensive task of your data set annotation. Then we have full-fledged companies. Those companies just take your data, use their past experience and their in-house tools to label it and provide the high quality annotated data set to you. So there are so many companies like Figurate is there, then Scale.ai, Labelbox. These are international companies, and just go to their website and you can just see that what they are offering you, what is the cost of dataset labeling, and you can just provide it your dataset and they can label you. Then there are so many Indian companies also that are in data annotation, because it's a labor intensive task and it is something that Indian IT companies are good at. So there are so many Indian companies, like Infosys is the biggest Indian data annotation company that particularly focus on data annotation. You just provide your data set and at a very cheap rate, they will annotate you. So if you have got a project from government, you have lakhs of funding from government, and you are required to create a model for that particular project as soon as possible. So what you can do is you can just go to these websites. We will see some of these websites and just provide your data to them, and what they will do is they will annotate it for you. They will require some manual annotation that you will provide, that this is how I want everything to be annotated. Then they will annotate it to you, and then they will provide it to you. Then so Infosys is there, Payment is there, iMerit is there. You will see Infosys shortly. So these are the companies that are available. But let's say you don't have the money, or maybe you have enough time and enough big team that you want to do in-house annotation. Then what you can do is you have so many tools to perform annotations and labeling. We have a tool called Cvet, computer vision annotation tool, that is by Intel. This is the tool that we primarily use. So you can use this tool. Then Label Studio is there. Then Label Me is there. These three tools are free of cost and directly available. If you just go and search online, you can find these tools, and these are free of cost. You can start using them. Their interface is even intuitive. and I don't think that you will even required to to read documentation properly. Even looking at the interface, you will be able to understand what is happening. Then if you require additional features, maybe you require like very sophisticated, you're required to create a very sophisticated 3D segmentation data set or something like that, then you have paid annotations tools as well, like Hive, V7, Labelbox. These are the tools that are paid. So you can go for free if you are creating some normal project, but very sophisticated data sets, you can go for the paid versions, or you can offload it to the crowdsources companies or to the freelancers on Amazon Mechanical Turk. So Amazon Mechanical Turk, we have just said that it's just a freelancing website. You can provide the whatever you want to do. You can do any manual labor task. You can provide on the Mechanical Turk. You can create a task and say that this much I want to pay to you. And if the person will be interested in front of you, then he will perform that task. You can do annotations, you can do translations, you can do summarization, so many things you can do on Amazon Mechanical Turk. Then this is figure 8. This is like the biggest data annotation company, one of the most popular data annotation companies all over the world. So if one is working if one is working on a very high end project and cost is not a constraint, then definitely you can avail the services of figure 8 for data annotation. Then Infosys is there. I've told you that this is the Indian company. It is the most popular Indian company, and they provide you the best data labeling platform from any Indian company. And just you can go there. You can ask their sales teams. They can take your data. They will provide a very high end annotations and create a data set in whatever format you want, and they can provide it to you. So these are the like crowdsourcing options that you can follow. And next thing is, let's suppose you want to do in-house annotation, then what are the strategies one can follow? So strategy 1 says that you can annotate old data. If you have, let's say, limited data, something that can be annotated within acceptable amount of time, maybe 2 months, 3 months, then what you can do is you can annotate all data and train your model upon that data and deploy that model. This is normally what small companies and small projects, uh, you can say, work upon this strategy. So we annotate all the data, train and deploy the model. If the requirement arises, we like improve the data, again train and again redeploy. This is the strategy 1. The second strategy is called data flywheel strategy, and this is only applicable to the big AI firms or AI companies. They perform this, they also adopt this strategy. This is called data flywheel. So this is my phone. I hope that I'm not looking bad, I'm looking good. So this is my phone snapshot, and in this snapshot, what is there, you can see that if you go to your Android phone and if you go to the photos application, then if we go to a particular person, it automatically separates different persons. Then it gives this thing. It provides you something called this sort of a you can say this sort of a dialog box in which they say that kindly tell us that whether the given person is actually the person that it has automatically grouped or clustered. Okay, so what I'm trying to say here is, let's say if I'm Anubhav and I have not annotated any image, and all the images are in my phone. So in data flywheel, what happens is this: initially, some sort of a data annotation strategy is there. Then after that, the end users participate in data annotation, and the overall quality of the model is improved. So what I'm trying to say is, if like whenever you will open this application and whenever you click on any person's name, you always get a dialog box in which it asks you whether this person is same or not. And then if you click this dialog box, this particular dialog box, it asks you 5-10, it gives you 5-10 images and tell that whether this is Anubhav, whether this is Anubhav, whether this is Anubhav, whether this is Anubhav. So this is data flywheel strategy that is adopted by big companies, in which annotation is you can say is also a annotation strategy is also a part of the end users. They also participate in it and try to improve the model. Okay, now let's say that we are just like we quickly move on to the dataset creation. So if you talk about classification, so creating a dataset for classification is the easiest task. It is the easiest task. Why it is the easiest task? Because if you talk about image classification, then you do not have to. Okay, so I got disconnected. I hope I am again audible. So for image classification, it's very easy to create a dataset. What you can do is you can just gather the images, whatever you have captured, and you can just create different folders or different directories for each class, and just put those images inside those folders and those directories. After that, all the popular deep learning and computer vision tools, including OpenCV, including TensorFlow, and including PyTorch, they all have inbuilt functionality to read such a directory and automatically create data set from that directory. Okay, so in Torch Vision, for example, if you talk about PyTorch, in Torch Vision, we have this option that if we just provide the if we organize our data set in such a way that the directory represent the class and the images inside the directory represent the images that belong to that particular class, that what you can do is you can just provide the directory, the name of the directory, and the data set will be created for you. That is the easiest thing. Okay, now one thing that I want to quickly show to you, if you have a data set for any purpose, doesn't really matter if you have a data set for your classification, or you have a data set for your segmentation, or you have a data set for your object detection. If you have a data set and you quickly want to test the quality of that particular data set, then you can use a software called that software. Okay, so we were talking about NVIDIA digits. So if you have a platform, if you have some sort of a code, and no, not code. If you have some sort of a data set and you want to quickly test its quality, then you can use NVIDIA Digits platform. It's a local software. It does not run on cloud, but you can always use it to just test the quality of the data set. It's a GUI based software, and inside that GUI based software, what you can see is you can quickly see what is the accuracy you are getting, what is the performance of the you are getting on a particular data set for annotation, object detection, segmentation, and so on and so forth. So you need to first install it on your local system, and then you need to simply like point out the directory. It's a GUI software. All right. So NVIDIA Digits the software that without using coding you can test the quality of a data set. What you can do is it looks something similar to this. I'm just showing you a demo, and it's a very simple and intuitive software, and you can just provide any data set, any object detection, any segmentation data set, or any you can say any any tracking data set, any object tracking data set, and it can provide you a glimpse that how actual model will perform on that particular data set, and it will not require you to actually write even a single line of code. So this is how the interface looks like. And what you do is you simply select the data set, and then you simply select the model, and then you just train on those models. So if I show you, let's say this is my data set. So what I can see is if I open this particular data set, this is my data set, and okay, so this is how like our you can say data set. You can just provide your data set here, and you can even create your own data set. Let me show it to you how you can use your own data set. Just go here and just click on classification and provide your own data set that you want to do classification, or you can provide your object detection data set path that you want to do object detection, segmentation, or object tracking, and different type of tasks it supports. So let's say I want to create a classification data set. Then what you can do is simply create classification data set, provide that what is the data set, then okay, just one second. Yeah, so let's say you want to create your classification data set. So you can simply go to data set and create the classification label. Then you can simply provide the path where your data set is available. So you can just provide the folder that here is where my data set is available. So let me copy the path, something similar to this. Then provide that these are the minimum number of classes, maximum samples that can be allowed per class, how many of that values of the data set you want for validation, and how many you want for data for testing. And then you can simply create a data set, just provide it a name, let's say test, and create it. Okay, so it will be created, and once the data set is created, what you can do is you can simply explore the data set, that this is my data set. And after data set, you can explore, you have explored the data set. What you can do is you can, without writing any code, go to the section of models, decide what model you want to work upon that data set. Let's say you want to work upon classification model, and then provide the necessary things, that this is the name of the data set, this is the epoch you want to train. Okay, these are the available models. There are so many other models also that are available. So let's say you want to use TensorFlow model, let's say Google Net model, then provide it model some name, let's say test image 2. Just create the model, and after you have created the model, it will start training. And without writing even a single line of code, you can see that how much accuracy you are getting, or how much you can expect accuracy when you will do the right amount of coding. Okay, so there is some error. Let me just quickly see. Cafe Google Net image test 3 and degrees of images. Okay, let's say test group. Okay, so what we are trying to say is, so NVIDIA Digits is a particular software that you can use to test the quality of a data set without writing any single line of code. If you have an annotated data set, just provide it this tool, this data set, tell it what you want to do. You want to perform classification, segmentation, tracking, or object detection, and it will quickly give you the result. It will not be the optimal result. You may have to actually write a actual PyTorch or TensorFlow code, but it will be giving you an overall idea that whether your data set is of good enough quality or not. So it has started training, and after some time it will train and you'll get the results. Okay, so let's wait for, okay. So you can see that it has started training. With the course of time, this model will get trained, and you'll be able to see that what is the answer. So the loss is decreasing and accuracy will increase, and with the course of time it will get trained, and after it gets trained, you can just test it out on any random image or any random particular frame, that whatever is the output you are getting. So this is called your NVIDIA Digits. Moving on, the next tool that I want to discuss, that is very important. That tool is called your Intel Cvet. This is the real tool that we use for annotations, for video annotations, for your image annotations, for 2D annotations, for 3D annotations, for segmentation, for tracking. It doesn't really matter what you want. This is a complete tool. If you talk about computer vision, if you talk about data set creation, go to this tool. 99.9% this tool will suffice. It is a free of cost tool that is being maintained by Intel. You have to just go to cvet.org. I will just show it to you what is the process. So just go to cvet.org, and after that you can do so many things for data annotation. It even have some AI based features, artificial intelligence based features, where it can semi automatically do majority of the work from you. You have to give your input, but semi automatically it will do majority of the work for you. So let me show it to you. So this is the interface. I'm just zooming in a little bit. This is the interface of this tool. And let's suppose you want to annotate this video. This is the video. I want to annotate it. Okay. So this is the video that I want to annotate it. Go to the projects, create a new project. So let me create a new project. Let's say Atal FDP. Okay. Then provided the labels, that what will be the labels that you want. You can provide them later also, but let's say then you can provide it initially. Let's say I want to, what do we want to annotate here? We want to annotate chickens. So just provide chicken. Let's provide it a label called chicken. On only one thing we want to annotate, and we are calling it chicken. Okay, then let's say done, and then we submit it. A new project will be created. After a project is created, we open it, and after opening a project, we create a task. Okay, what happens is this, that a project can consist of thousands of images or thousands of videos. A task will contain a subset of those images or a subset of those videos. So if I show you here this particular video that is showing on your screen, we had let's say more than 200 such videos. So many videos were there. So it was not possible like to annotate all the videos in one go. So you have to separate the complete project into separate tasks, into individual tasks. So let's create another task. Let's create one task. Okay, and let's say chicken detector. This is the name of the task. That will be a separate, you can say subset of the entire project. And then you just provided the whatever images or video want to provide it. Let me just provide it this particular video that is currently running. So this video is running. Let me provide it this video, and then let me submit it. So after some time, my video or videos will get submitted. So my video is submitted. Now the interesting thing arrives. Once a job is created, once a task is created, then what you can do is you can create different, you can say jobs. Or job means this, that you can assign whatever the video I've just uploaded to different persons. So let's say I want to assign it to myself. So my name is Anubhav. So I can just write out the name Anubhav Patrick. So this particular job will be assigned to Anubhav Patrick, and then there is something called a reviewer. Reviewer reviews the task. Once you have annotated, some other person will review the task. Let's say my friend Aditya Lohia will, let's say Aditya S. Lohia will review this task. So all the users inside your Cvet, you can assign the task, and that particular reviewer, if he wants, he can review your task. So right now I don't want anyone to review my task. So I have assigned it to myself. So let's say what now we have to do. So just let's go to this particular job. Okay, so let me go to the task. Now, so after you have created projects and then you have given a job, then whenever I want to annotate it, I have to go to the task and then just open that particular task. This is my task, and let me just open it. Okay, so this is the interface of the tool, and it's a very important tool. It's a very advanced tool. So what you can do, let's say you want to simply, like this is the complete video. If you see here, this is the complete video. Like it will take some time, but after some time you can see that it is a complete video that we have uploaded, and frame by frame you have to annotate each frame, and then after annotation, on the left hand side we have the annotation tools, and right hand side we have the properties of those annotations. So you can see this, the complete video is there. So after we have annotated the data set, you can simply go here in menu and export your data set in different formats. Coco dataset format is very popular. Then Cvet format is there. Then YOLO format is there. So there are so many formats in which you can export the data set, and after exporting the data set, you can feed it into any model, including NVIDIA digits. You can just feed it to NVIDIA digits software as well to quickly see how our data set is performing. Okay, so let's say I want to let me go to the first frame and I want to annotate chickens. So what I can do is, if we are talking about normal annotation, what I will do is I will be requiring simple rectangular annotations. I will click here and I can simply just annotate it something like this. So this is my first annotation. Okay, then another, this is my second annotation. Okay, so this is how you can do it manually if you want. But this tool also provides you lots of AI based services, so you don't have to actually manually do the annotations. What you can do is you can click here. This particular thing is called your AI tools on the left hand side, and in AI tools you have different options. We have detectors, trackers, interactors. Let me tell you what these things are. Detector means if you have some common, let's say YOLO. Let's say you have some common thing that you're trying to annotate. Let's say a person is there, bicycle is there, car is there, bus is there, something common. So you don't have to manually do it. It is inbuilt functionality. What you can do is you can just select AI tools and then detectors, and then just select which tool you want, and simply select that particular class in the detectors, that particular class. Let's say I want to annotate fire hydrants. So just like tell it that you want to annotate fire hydrants, and then just provide it some label, and then it will just click on annotate, and if there is some fire hydrant that it finds automatically, then it will annotate it automatically. Then we have one important tool, something called trackers, AI tool tracker. That is again very important. Why it is important? If you, let's say you don't want to annotate everything manually, every frame manually, but because it's something that's a complex process. It's a very lengthy process. So what you can do is you can just go here and go to tracker and just select here trackers. Okay, and then create a bounding box on any object you want to track, and just click upon it, and then what it will do is it will automatically try to track that object across various frames, and then label that particular tracked object accordingly. So you don't have to go frame by frame by frame by frame and actually annotate each object. You can simply use the AI tool. Now, like I have tried to I've used the AI tool tracker here. So what you can do is you can simply see here, it will all the frames I have just, if you have seen, I have just used it once, but in all the frames it is trying to track. Now it is not accurate. You can see that it is not accurate. Let me use another AI, another this tracker on another chicken. Let me use it like, let's say uh, on this chicken, let's say on this chicken, on this chicken. So this AI tool is not accurate, but it sometimes reduces your efforts to a considerable amount of time. So you can automatically just track the object across various frames. You don't have to annotate every frame of a video. So it will save you tons and tons of time. So this is what we learned like when we were like developing that project, that we could even use those AI tools and we don't have to manually annotate each object. So let's see what is the output of this tracker. So this is the output, and the chicken is not moving, so it is tracking it actually correctly. Even if the chicken moves, it will most probably track it properly. So I don't think there will be an issue. Okay, so this is second AI tool. Then there is more AI tools, like interactor is there. Interactor, this interactor. So what we'll do is this particular interactor. Okay, so let's say you want to you don't want to create a bounding box, you want to create a boundary across a particular object. So you can use the interactor tool. Interactor tools is simply you provide some points that this is my object, and it will automatically create the entire boundary for you. Just I have provided you 4 points, and it has created, if you can see here, it has automatically created the entire boundary for you. It is very useful when you are creating segmentation data set. So this is all about your that Cvet tool, that is from Intel, and it's a very popular tool, and almost all the people that I know in computer vision particularly use this tool. So you can use this particular tool, and like you can there are very good tutorials available. There are very good documentation available. So you can just go to the documentation and learn about it. Okay, so just quickly move on because our time is about to get over. So let's say you have created the data set. What you have to do, once you have annotated it, then you simply go here, and once you have annotated it, go to menu, go to export as a data set, and just download whatever you want to download. Let's say I want to download this data set as a COCO data set, standard compliant data set. So just I will click here and my data set will be downloaded. So you can see that soon my data set will start downloading. And let's say you have a data set, then the next question arises where to share that data set, because sharing the data set is very important. So it's a 258 MB data set. It's a quite large data set. So let me see. Okay, yeah, so it's quite large data set. It will take 5 minutes. So ultimately you'll get the data set. So let's suppose you have the data set. Then what is the next task? After getting the data set, next task is to share that data set. Normally what happens is this, that if you are putting your heart and soul into creating a data set, you want it to share it with the world. In actual, when we are talking about in actual machine learning projects that we create for companies, in those projects data is private and we do not share it. But if you are an academician or if you are a hobbyist who is trying to develop a ML project, you will definitely want to share your data set so that other people will also use your data set and you will get some recognition. So for that there are so many tools, but for academicians particularly, IEEE data port is the most important tool that you can use for sharing the data set. Now, why IEEE data port? Apart from that, you can share your data set simply using your Amazon S3 storage or Google Cloud storage, or maybe Azure storage or Google Drive. You can share your data set, or you can share your data set on Kaggle. Kaggle data sets are there. It has 100 GB limit, so you can share it on Kaggle. Okay, or you can like host it on your local server and provide it to the world. It's well and good, but why to use IEEE data port? Because in academia, the major focus is to get publications and get citation and get recognition. And sometimes, and not sometimes, around 50% of time, even if a person uses your data set, it does not give you, he or she does not give you recognition. So IEEE data port is a very, it's a very interesting project. Here anyone can create an account and upload your data set. What data set that we are just downloading, that data set we can upload here. It has 2 TB size limit. So majority of the normal data sets will fit in IEEE data port. And once you have uploaded your data set here, then you will get automatic citations. You don't have to worry that whether I will be cited or not. If anyone is writing any IEEE conference paper or IEEE journal paper and has used your data set, that he will definitely share it to, he will definitely cite you using their automated tools. They provide the metadata that a person can simply use that metadata to cite you, and you will get recognition and citations for your work. So this is something that is very important. So if you want, we can just quickly see here. So our model is still downloading. I will not go into detail, but you can simply go here to data sets, and in data sets, you can go to upload new data set, and you just need to, okay. So this is data set, let me see. IEEE data port, let's go to IEEE data port. Submit a data set, yeah, go to submit a data set. And inside submit a data set, even if you want free uploading of data set, it is available. So you can just click here on standard data set, submit a standard data set, and you need to provide a zip file. Okay, so just provide your name, your last name, then you can provide your ORC ID, that's your unique identifier for your publications. Then just provide a name of the data set, chicken data set, and then provide the category. Let's say I am talking about computer vision. Sorry, I'm talking about computer vision. So just provide it a category. Okay, then there's no link. Then provide it some abstract, anything you want. Let's say test data set. Okay, then documentation and instructions. What instructions you want that like people to know when they are using your data set. So just provide any instruction. This is our test data set. Okay, then upload your dataset files. You can upload any file, any zip file here, any zip or compressed file here, or You can even provide, if you have stored your data set on Amazon storage, Amazon cloud storage, that is Amazon S3, you can provide it the S3 repository link or the S3 directory link. Otherwise, you can just click here on choose a file. And after you will click here, you can just tell that which data set you want to upload. And let me show it to you. So let's say I want to upload this data set. Just tell them that you want to upload this data set in COCO format. Okay, then you want to upload it. Yes, I don't want to share it to any upload contest, so I'm not sharing it with the upload contest. I do not want any mailing to subscribe to any mailing list. I agree with IEEE terms and conditions, and just save it. And soon your data will your data set will. Okay, I'm not. I think I'm not selected it. So okay, so it has started uploading, and it will upload, and you will get a notification that your data set is uploaded. And once it is uploaded, you can, like, anyone can use, whoever is using IEEE website, they can use your data set and they can cite your data set, and you will get recognition, citations, and reputations out of your IEEE data set. Okay, so that was all about IEEE data port. And lastly, like, we have seen that there are other places to store data set. Our company, the Ferromatics, gave us data set through their Google Drive link, but there are so many other places where you can share your data set. And lastly, I want to focus on that there is a popular competition going on, that is your data-centric AI competition, where the creators of those competitions are focusing on data set creation and improving the quality of the data set rather than focusing on the models. So this is the challenge link. You can go to the AI centric data challenge, and you can, like, participate it in and try to improve the data annotations and the data quality of the various data sets that they have provided to you. And if you win, then there are certain certain advantages. There you can meet Andrew NG, and even you can you can get so much recognition on a global scale. So this is a challenge, that is a data-centric challenge that anyone can participate and focus on. So that was all about our data set creation process. For the short time, we didn't go very deep into different tools, but definitely we can focus on them. Like, we can just go through them, go to the documentation, and read about them and start building our own data sets. So if anyone else has any query, just tell me. I can answer your queries. Madhu ma'am, is there any query? Okay, yeah. So Raghavendra Divedi has asked some question. Yes. Raghavendra sir has asked some question. Kindly unmute Raghavendra sir.
Sir, we have given you the mic, please.
Yeah. Yes, Raghavendra sir.
Good morning, sir.
Yes, sir.
Hope I'm audible.
Yes, sir. You're clearly audible. Yes, sir.
Yeah, thank you. Sir, just one question regarding a data set. That which is the best way to highlight our data set in a research paper? Either in reference section or either in data description section. Since some journal discourage the things like we put URL of the exact data set, so that they discourage to explain the things. So what is the way to make it in reference
Uh,
especially?
Sir, actually, as far as if you ask my personal preference, but whenever I have written any research paper, I have always mentioned about the data set and the creators in the experimentation section. So once we have created any experiment, once we have provided some solution, so what you can do is you can just go to the experimentation section and provide and give your reference of the data set in that section. So I believe that experimentation section is the best section to share your data set, whatever data set you are currently working upon.
Okay. Should we give the URL of that?
No, I don't think that you like in the reference. You can normally what happens is this that like you don't give the URL of the data set. You provide the details of the creators of the data set. Like this is the
Yes,
data set.
definitely.
Yeah. So definitely you can provide it in the form in that particular like whatever data set creators are there. You can provide it their details along with the name, and
Mhm.
simply you can do it. Even if what you can do is that you have Google dataset search. You can go to Google dataset search and just you can cite it from there. Like if you go here dataset dot google dot com. Okay, so dataset dot research dot google dot com. Research Google dataset. Okay, so this is the dataset search, and let's say COVID-19. If we are talking about any COVID-19 dataset. Okay, so here we have the option to cite the dataset. Okay, so
Mhm.
just click
Yes.
here and just cite the dataset and just provide it there that this is the dataset and this is it, and simply use it in your research paper. So you don't have to actually give the URL of the dataset. Just go to Google dataset, whatever dataset you want to apply, just copy whatever the citation information is given there and simply use it directly in your research paper. I don't think anyone will have any objection.
Yes. Yes. I think it's a great way.
Yes, sir.
Thank you. Thank you so
Okay.
much.
Okay. So I don't think anyone has any question. So shall we close our session?
Okay, thank you very much, sir. It was a wonderful session. I hope participants got the clear understanding about the topic. Thank you very much, sir.
Okay. Thank you. Thank you all.